I'm going to put out, let's forget about those for a minute, okay? I'm going to put out my yellow blocks like this. Okay? Now, I'd like you, after I do this, to put out some of the blue blocks in a line so you have just as many blue as I have yellow.
As adults, we know that changing the arrangement of objects does not change their number.
Okay?
8 objects remain 8 objects, irrespective of their arrangement. This principle is called conservation. Research by Jean Piaget and others shows that most children under 8 years of age do not conserve quantity. We will explore 3 stages in children's understanding of conservation between 4 and 8 years of age.
Okay, do we have the same number of blocks now? No? We don't. Can you make it so that you and I have the same number of blocks?
Yeah.
4-year-old Kevin is near the end of the preconceptual stage. Though there are 9 yellow blocks and only 8 blue ones, Kevin simply rearranges his to make the 2 groups appear equal in number.
Do we have the same number now? How do you know?
Because look at them.
Okay, I can look at them. And what do I look at when I look at them?
You look at the rows of them.
Okay, fine. Now, tell you what, why don't you count yours?
1, 2, 3, 4, 5, 6, 7, 8.
Okay, how many do you have?
7. I mean 8.
8, okay. Why don't you count mine?
1, 2, 3, 4, 5, 6, 7, 8, 9. 9.
How many did you have?
8 and you have 9.
Do we have the same number of blocks? What could you do about that?
I could fix them.
Okay, fix them.
Kevin's counting is accurate, and he knows that the 2 groups are different. To correct the inequality, he matches each of his blocks with a yellow one, setting up a 1-to-1 correspondence.
What are you going to do about that?
I think I should take another one.
Okay, now I'm going to put all these over here so we don't have to worry about them. Now, do we have the same number of blocks, or do you have more, or do I have more?
Well, I'll count mine again. 1, 2, 3, 4, 5.
Even though each blue block is matched to a yellow one, Kevin counts to see if they are equal in number.
1, 2, 3.
While his use of 1-to-1 correspondence is somewhat advanced for his age and suggests that he is leaving the preconceptual stage, it does not convince Kevin that the 2 rows are equal in number.
7, 8, 9.
And how many did you have?
9.
Do we have the same number of blocks, or do I have more, or do you have more?
We both have 9.
We both have 9. Does that mean we both have the same number? Okay. Now, would you watch what I'm going to do? Watch. Now, do you have more blocks, or are they the same, or do I have more blocks?
I have more blocks.
You have more blocks? Show me why you have more blocks.
Because you put yours together and I put mine apart.
So you have more? Okay. Now watch what I'm going to do.
During the preconceptual stage, children confuse quantity with space. Changing the spatial arrangement of objects changes their amount. Or in other words, what looks bigger
Now.
is bigger.
Do we have the same number of blocks, or do you have more, or do I have more?
We both have the same number.
We both have the same number of blocks? Now watch what I'm going to do. Now, do we have the same number of blocks, or do you have more blue blocks, or do I have more yellow blocks?
You have more yellow.
Why do I have more yellow blocks?
And you put yours, mine together, and you put yours apart again.
Okay. You know, the same child who I talked to earlier said that if we started with the same number of blocks, and all I did was push them together, that we still have the same number. What do you think about that?
I think they're kind of strange.
You think they're kind of strange? Okay.
Later in the interview, Kevin compares the 2 groups of blocks. He miscounts his 9 blue ones.
7, 8. I guess I have to start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10!
10? think about that?
I think I should count yours.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9. No way, I got 10, you got 9, I got more.
You told me that I had more.
No, I have more because I have 10 and you have 9.
Okay, why don't you match them the way we had them at first and see who does have more.
Kevin attempts to reestablish the one-to-one correspondence between blue and yellow blocks. However, his understanding of one-to-one correspondence is not yet well developed.
Check them very carefully. Look at them very carefully.
One more.
You have one more? How about that?
Make them even. Make them equal. Make them
There's 9 here.
We'll make it so you have just as many blue blocks as I have yellow blocks.
BB is 7 years old and in the intuitive stage.
Okay. Now are they the same? How do you know they're the same?
Because I counted them.
And how many did both rows have?
9.
Okay, let me take these blocks and I'll move them out of the way. Now watch what I do with my blocks, alrighty? Okay. Now, are there the same number of blue and yellow blocks, or does one have more?
BB is not sure that the number of blocks is the same, even though only their arrangement has changed. She counts to find out.
Yeah, still the same.
How do you know that?
Because
How could you tell?
I just counted them.
Oh, that's how you found out. Okay, now watch what I do. Now, are there the same number of blue and yellow blocks, or does one have more?
The yellow row is now longer, but with more space between its blocks. We know that these changes cancel each other and number is conserved. BB cannot coordinate these relations and instead must count to see if the number has changed.
How did you find that out?
Because I keep counting them.
Very good.
Well, just make sure that you have the same number. I want you to have the same number of blue blocks as I have yellow blocks.
There.
Is that the same number?
Yeah.
And how do you know?
Because there are 3 rows here and 3 rows here and 3. There are 3 rows of 3.
Okay, very
So-
good.
Shelley is almost 8 and in the concrete operational stage.
How many?
9.
Are there? And how do you know that?
Because that's what for instance, 3 times 3 is.
Is there some other way that you could show me that we have the same number of blocks without counting them?
Without counting them?
Is there some way you could show me
Sure. Okay. It's like
that we have the same number?
there's 3 here
Yeah.
and there's 3 here, right?
Is that counting? Okay, well, that's all right.
And then there's 3 here
Yeah.
and then there's 3 here.
She establishes a one-to-one correspondence between 3 sets of 3 blocks.
Okay, now, I'm going to take my blocks and I'm going to change them out like this. Okay, now do we still have the same number of blocks, or are there more yellow blocks or more blue blocks?
More we still have the same number of blocks.
We still have the same number of blocks, and how do you know that?
Because even just as long as you don't take any more or give any more away, then we still have the same number of blocks.
Okay.
Without counting, Shelley knows that if nothing is added or subtracted, the number remains the same.
Would there be a blue block for every yellow block?
Yes.
Okay, let's line them up that way.
Okay. I like there, there, there,
Maybe I'll move these down
there,
here.
there, 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 and there.
And how can you tell there's a blue block for every yellow block? Show me.
See, here's 2 there. There, 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 and there.
Okay. Now, what if I did something like this? I'm going to take yours, and I'm going to spread them out further like this. Watch what I do. And I'm going to put in a yellow block there. Now, what do you think?
There's not a blue box for every yellow box.
What, how is that?
You want me to show you how?
Explain to me what you mean.
Take a look.
Well, explain first before you do that, can
See.
you? That you're saying there's not a blue block for every yellow block?
Yeah.
Okay.
Only if you took one away, then there would be.
If I took one away, there would be.
Yeah.
But
if
there
you-
isn't right now.
No.
Well, somebody, the other day, a little child told me that, listen, she said, you have blocks that start from here and they go all the way around like this, and they stop here, and they start to the same and they end at the same. So that means that there's the same number of blue and yellow blocks. Is she correct? Was she correct in saying that?
Sometimes, yes.
Do you think she was correct in that instance?
Right, you mean in...
Would she
right.
be correct about this if she said that there were the same number of
No.
blue and yellow blocks?
I don't know.
And what would you tell her? How would you tell her she was wrong?
I would show her
Okay, show her.
like that.
Rather than counting, Shelley uses an argument of one-to-one correspondence. Her ability to reason about number without concern for spatial arrangement or need of counting characterizes the concrete operational
More
stage.
yellow black than I do.
And we take it away, and they'd be all the same.
Right.
Okay, now, are they the same now?
Yes.
Okay. Now, you wanted the blue one?
Yeah.
Okay, let's set your blue one right there. Now watch what I'm going to do with the yellow one.
4-year-old Claire is questioned about the quantity of
What
clay.
am I going to do?
This is a conservation of substance task. Children in the preconceptual stage believe that the amount of clay changes when its shape is altered.
Now, is there more Play-Doh in the blue? Or are they the same? Or is there more in the yellow?
Blue and the blue,
Why?
because that's a snake.
There's more Play-Doh in the blue than there is in the yellow?
Yeah.
Okay.
Can we make
Claire judged the two balls as equal, but when one was rolled out, she thought there was less clay.
Back into a ball.
She doesn't understand that while the snake was longer, it was also thinner, and that these two physical changes canceled each other, leaving the amount conserved.
Is there the same amount in each, or is there more in the blue or more in the yellow?
more in the blue?
There's more in the blue? Why is there more in the blue?
Because that yellow makes a snake out there.
I made a snake out of it. But now look it isn't a snake anymore, is it? I made it back into a ball.
I'll make it into a box.
Well, okay.
With this.
Okay.
Now they're the same.
Now they're the same? Okay. Now
Claire
watch what I do
momentarily
with yours.
thought that the yellow ball was still less because it made a snake. However, when she rolled it, the yellow clay became equal in amount to the blue clay.
Okay, what is this?
Play-Doh.
Play-Doh. And is there just as much blue Play-Doh as there is yellow Play-Doh? Are they just the same amount?
This one needs a little more too.
It does. Well, what could we do to make them the same?
Get some more Play-Doh.
How about this? If I took a little bit away from here, now would they be the same?
Yeah.
Okay, they're both the same now? Alrighty. Now,
Earlier, we saw that BB can count and determine whether two groups of blocks are equal in number.
I'm going to turn it
In this conservation of substance task, she knows that clay must be added or subtracted to make unequal amounts equal.
Snake skin.
This is an advance over preconceptual reasoning.
Okay, now
I
look at
think
these
he does it.
two and tell me, are they both the same? Is there just as much blue as there is yellow, or is one more?
This one's more.
How do you know there's more in the yellow?
Because you squeeze this one out and this one's still in a ball.
So why is there more here?
Because this one's longer than that one.
Okay. now
Earlier,
that
BB suggested adding clay to make unequal amounts equal.
longer.
Yet she now thinks that changing the shape changes the amount.
Still, this is a lot. This is still the most.
Okay, I'll do one more thing with it. I'm going to oil it up like that. Now, I'll show you. I'm going to take the blue one and I'm going to...
Can I scratch it up?
Okay, you squash it out flat. Put it down here and scrunch it up flat. Okay, that's great. Now, are these two just the same, or is there more blue or yellow, or what do you think?
There's more this than that.
Now, the other day, I had a little child say that they're really both the same. Why do you
That's
think
not
he-
right.
Why not?
Because this one's all flat down and this one's all rolled up into a ball.
Well, he said that this one's flat, but it goes bigger around. What do you think about that?
I still don't think it's right.
You don't? You think you're right, huh? You think there's more here?
Yeah.
Okay, what will happen if I roll it up again?
The child's conception of conservation develops with an anticipation that changes in one dimension can be compensated by changes in another. Bibi does not understand that as the blue clay becomes larger in circumference, it also becomes thinner. She focuses only on the large circumference and therefore judges the blue clay as more.
Into a big, long snake. Now, do we still have the same amount of yellow as blue, or is
Yeah.
there? We do? There
Yeah.
isn't more in one?
No,
How can you tell that?
because they were the same when they were in a ball.
8-year-old Robin knows that the amounts are still equal since they were equal before. This implies an understanding that while the ball became thinner and longer to form a snake, the snake can become fatter and shorter to form the original ball. An understanding that changes in one dimension can be counteracted by those in another characterizes the concrete operational stage.
Now, is the red one longer, or is the blue one longer, or are they the same length? Okay, now watch what I'm going to do.
4-year-old Shauna is in the preconceptual stage.
Now, is the red one longer, or is the blue one longer, or are they the same length? Why is the blue one longer?
The blue one extends further out on one side and is therefore judged longer.
Okay. Now, Sean, I had a child with me this morning, and she told me that I started with them the same length, and I just pushed one out of the way, and they were still the same length. What do you think about that? Are they still the same length? Now, if I put them back like that, are they the same length, or is the blue one longer, or is the red one longer?
This longer.
Put the ends together to make sure. Just put them down, put the ends. Now, are they the same length, or is the blue one longer, or the red one longer?
Same length.
Okay, now watch. I'm going to leave this one like this. I'm going to take this one.
At the preconceptual stage, children have no way of understanding that spatial changes can compensate each other. While the straight blue wire extended beyond the end of the red one, this was compensated by the red extending beyond the other end of the blue wire.
Like that. And I'm going to put right there. Now, is the red one longer, or are they the same length, or is the blue one longer?
Say it's longer.
Which one's longer?
Red.
Why do you think that, Shauna?
Because this is pushed down there.
Okay, now let me play a game with you. Can you imagine that you're a very tiny, tiny worm? Can you imagine that? And if you were a tiny worm and this was a road and you went for a walk on the red road and you went for a walk on the blue road, would you have a longer walk on the red road or a longer walk on the blue road, or would they be the same?
Longer on the blue road.
On which one?
This
Which one's that?
one. The blue.
Oh, okay. You'd have a longer walk on this one? Why would you have a longer walk on that?
Because this is straight and that's little.
The bent wire is judged as little because it matches the red wire at one end, but is shorter at the other. This judgment does not take account of the relationship between the bends in the wire and its appearance of shortness.
And put it right down here. Now, are they the same length, or is the red one longer, or is the blue one longer?
Both the same length.
Because both ends match, Shauna knows that they are the same length. 7-year-old Bibi does not conserve substance or number even though she can count. To further investigate her quantitative reasoning, she is given a length measurement problem.
Okay? Watch what I do this time. I walk. And this time I don't want to walk quite as far, so I stop right there. Now you make your man walk just as far. Has he walked just as far?
I don't know.
What do you think?
To use this.
You can use that if you like.
Okay.
And how does that tell you whether he walked just as far?
Easy, just from right here. Yeah. Goes right.
Now, if my little man walked from here, do you have him just right now? Yes, keep him on the path. If my little man walked all the way to here and your man walked from here to here, would they both be just as tired or would one of them be more tired?
This one would be more tired
And why is that?
because his path is more longer.
Is it more
Unlike
longer?
Claire, Bibi has an intuitive sense that the crooked path is longer. However, this understanding is not yet accompanied by a conception of units.
Make your man walk
Rather than thinking of the crooked path as an addition of shorter distances, she treats the two paths as if they are straight and places her doll so that the two are exactly opposite each other. The stick is used to emphasize this placement.
Does your man walk just as far?
Yeah.
Okay. Okay, now let's go back to the beginning again. Let's walk back to our houses.
You're turning backwards.
Oh, I'm walking backwards. Okay, I'll walk frontwards.
I beat it.
You did beat me, that's true. Now this time, I'm not going to walk quite as far. Watch what I do, okay?
Can I walk next time?
Yes, you can walk next time. I walk right to here, and then I stop.
Oh, they're both the same still.
But I walked and you didn't walk at all. Would you make your man walk just as far as my man walked?
I can't make him walk. It's like if I made one pee-pee, this one would be longer.
Would it be really longer?
Yeah, look. We can't even, this is the same.
How about if I do this? A little child said to me, listen, my man walked this far, from there to there. So we put him right here. And your man needs to walk that far in order to walk just as far.
Yeah.
Did this man walk just as far as this man? If you put him there?
No, this one would go too far. This one would be too far.
He went way too far. Okay, this time you take your man for a walk. We'll go back to our house.
Yeah.
And you wanted to walk this time? Okay, you walk, but don't go all the way. Okay, you walk. Take a little walk down your path.
I'm making a stick. Too.
Okay. And I'm going to walk just as far as you have, okay? Here I go.
You didn't do it.
I didn't walk just as far as you had? Why do you say that?
Because look, this one's right here and yours is right there.
Well, look at this. Let me show you this. If I take the stick and I say he walked that far, and then he walked that far.
He was supposed to be right here.
Well, let's leave him here. Let me see if I can convince you. My man walked from here,
I'm moving
and then
for
he
you.
walked it there, and your man walked one of those, and he walked another one of those. Okay? Couldn't you say they both walked just the same distance? You insist that that one walked further. Okay, make it so my man's gone just as far as your man, but no further than your man.
Bibi's conviction is firm. She cannot be convinced that equal distances imply an equal number of units. For her, equal distances require equivalent starting and ending points.
I know.
Look.
Yes, I can see that. I can see that this man is just as far from the house as this man is from here to here. But in terms of the distance that they walked, didn't this man walk further? He walked the same distance. Okay. You're the boss. Whatever you say is right.
I'm going to take my
Earlier,
little
we saw that
soldier on
8-year-old Robin conserved substance. This indicates some understanding of units.
Now what I want you to do, Robin, is to make your soldier go just as far as mine has. Has he gone just as far as mine?
Yeah.
Okay. Would this help? Could you use this to measure and make sure?
Yeah.
Okay, try that.
Using the stick as a unit of measure, Robin knows that the same number of added units implies the same distance.
Yep.
Were you right?
Yeah.
How did you figure it out before you had the stick?
Because if he has curves to go and he just goes straight,
What would happen?
so he has longer to go to get to there than he does to get to here.
Oh, I see. Very good. Okay. Now
Robin
we
not
have
only
our
knows
soldiers
that one path is longer,
back to their
but she can
starting
also
place.
accurately predict an equal distance.
Now this time, my little soldier takes a walk, and he goes that far. Make your little soldier go just as far as mine. How do you know it's that far?
Because the last time it was that far and it's only this much, it's only this much less.
Do you need
Robin
to
shows that she can use fractions of units and that she can subtract units as well as add them.
Now this time, we bring our soldiers back to here, and my soldier's going to go from here to here. Make your soldier go just as far. How did you know he went that far?
Because that's as far as this.
Okay, do you need to measure to do that?
No.
How can you tell then?
Because that is only as long as that, and that's only as long as that.
Very good, Robin. Thank you.
Robin knows that one segment of the crooked path is equal to the stick, and one corresponding segment on the straight
These
path
over here,
is
and
also
in a few
equal
minutes
to the
we'll do
stick.
Another task with a jar and colored water.
During the preconceptual stage, the concept of quantity is tied to how things appear. When objects are rearranged, children in this stage think their number has also changed. Making a row shorter is thought to reduce the number of blocks. To think otherwise requires understanding that while one row is shorter, there is also less space between its blocks. This same type of reasoning is seen in the conservation of substance task. When one ball is changed into a snake, Claire thinks the amount has also changed. She doesn't understand that while one ball was lengthened, it also became thinner. Children in this stage also fail to conserve length. If one wire extends beyond the end of another, it is thought to be longer. The preconceptual child does not take account of the fact that it is longer at one end, but shorter at the other. Between 6 and 7 years of age, most children enter the intuitive stage. Conservation is now considered a possible but not logically necessary condition. Beebe counts to find out whether the spatial rearrangement of the blocks has also changed their number. Most children in the intuitive stage can count, but this does not necessarily mean that they have acquired the concept of conservation. Beebe can count blocks to determine whether their number has changed, but she does not conserve substance. A child's inability to conserve quantity implies that they cannot yet use units of measure in their thinking. Beebe does not think of distance as a sum of shorter distances or units. Instead, she places her doll so that the two are physically close to each other. By 8, most children enter the concrete operational stage and realize that one type of change can compensate the effects of another. This insight provides the psychological basis for an understanding of conservation. Shelley knows that additions and subtractions can compensate each other. This, in turn, leads to an understanding that if nothing is added or subtracted, equal amounts remain equal. The child's understanding that one operation can reverse the effects of another is called reversibility. Reversibility of thought is expressed in a number of ways. Robin knows that changes in thickness are compensated by changes in length. She also knows that the snake must be equal to the blue clay, since it could be changed back into an equal-sized ball. Conservation provides a basis for understanding units of measure. Robin uses the stick to measure the number of units in the crooked path. She knows that her doll must travel the same number of stick lengths on the straight one. During early childhood, the child's intelligence goes through a series of complex developmental changes. This occurs gradually and is shown in this film by the changing views of conservation and measurement. Research by Jean Piaget and others indicates that this development is not the direct result of instruction or maturation. Each level of understanding is constructed by the child in the course of active interactions in the social and physical world. Only by the child's application of his or her own thought will earlier forms of thinking be modified into more complete and systematic ways of understanding the world.